Hey y'all, so this is project 1 for UM 238, Data Analytics and Business 2. So for this project, I was put on the purple team. So our job was to see if the data provided could be used to make a prediction of whether or not a passenger on the Titanic survived or not. So for this project, I made the prediction that I thought I needed to use um, clustering or classification because there are many different variables which I think will affect whether or not the passenger survived or died. As you can see in these comments, I wrote whether or not I think each of the attributes would successfully predict that or not. So the first thing I did was import pandas. This will help me with just the basic functions. I also imported Seaborn and Matplotlib.pyplot, which will be used later in the video to do the heat map and the box plot. So the first thing I did was I read the CSV file given to me. As you can see right here, I did pd.read dash half underscore cs pd.read underscore csv. Okay, then I did the head to look for any anomalies in the data. As you can see right here in cabin, we have some NaN values, which mean they are missing. I did the same thing. Instead of df.head, I did df.tail, and I can see a couple more missing data values right there. So the next thing I did was do df.dtypes for data types to see if the data types corresponded how they should. The only data type that looked incorrect to me was the cabin, because it should have been a numeric type of data point, but it says object because there are missing values. So the next thing I did was provide a statistical summary of the data. I did df.describe. We have count, which shows how many values of each, mean, which gives the average value of each, STD, which is the standard deviation, minimum obviously gives you the minimum value, 25%, which is the lower quartile, 50%, which is the median, or the second quartile, 75%, which is the third quartile, and the maximum, which is the maximum value in each attribute. So the next thing I did was df.correlate or df.cor. I plugged in numeric only because you can only see statistical information for numeric values. So I looked at specifically the survive function because that's what we're trying to predict. As you can see, there is a correlation between survived and the passenger class, which is really interesting. So the next thing I did was try to drop any irrelevant columns. So I did most of this by looking at whether or not it's unique to each passenger. If it's unique to each person, it's obviously not going to help us predict anything because there's going to be no clustering available for that because they're all unique, so they can't be clustered. I also looked at the correlation matrix before. For example, there was no correlation in the Parch attribute, so I dropped that. I also dropped passenger ID, name, and ticket number. So you can see right there I did the head again just to make sure everything looks fine. So for question 9, I renamed columns to make it simpler. I changed the P class to passenger class, and I changed the SIB SB to sibling/spouse just so it would be a little bit easier for us to read. So the next thing I did was do a shape to see how many rows and columns we had. Then I deleted any duplicate rows because we do not need duplicate rows because they are not going to help us predict anything. Because we already have that data once, why we need it again. So I dropped that. And then I did shape again. As you can see, it deleted many different rows. So after I did that shape, I dropped any NA values. Since cabin is object data, I went ahead and deleted these rows because they cannot be replaced by average because cabin is object. It's not integer or float. Yeah. So I dropped those values, and then I only had 182 rows left. That's a big drop. So yeah, I did that shape again. The next thing I did was I formed a box plot. I used sb.boxplot, seaborn.boxplot, and then I used the matplot.show, and it gave me a box plot which helps visualize the outliers. As you can see, there were not a lot of outliers in most categories. However, the fair category did have a pretty big outlier range. So what I did, I wanted to remove any of those outliers since they would not be necessarily helpful in helping me cluster my data. So I did, I set quarter one, or the first quartile. I set the third quartile. I then made the interquartile range by subtracting the third quartile from the first quartile. I set my threshold as 1.5 as always. Then I formed a formula for outliers. I did the fair attribute is less than quarter one minus the threshold times the interquartile range, or the fair is greater than the third quartile plus the threshold times the interquartile range. So lastly, after I come up with that outlier number, which I just showed you how to calculate, I dropped any numbers that fell in that outlier range. For question 12, I want to see how many, well, to end question 12, I want to see how many were dropped. I had 166, so about 15 of those outlier rows were dropped. The next thing I did was created a heat map using Seaborn. I did sb.heatmap, and then it gave me this. Awesome. Okay, the next thing I used, I needed to do was to factorize the sex category. I did this by using pd.getDummies. Then I used the concat to do the getDummies data frame and combine that with the regular data frame. I then dropped the sex attribute since we were factorizing that, and then I factorized it, which is a numeric category. So this is what this male and female, that's the getDummies part, and then the factorized part itself is the sex 0, 1. So for question 15, I needed to turn age into a categorical attribute. So first I did pd.toNumeric, and then I did pd.cut, and I set my bins at 0, 20, 50, and then 99, whatever. Obviously no one's that old, but I just wanted to do a maximum really easily. So these bins being 0 to 20 would be young, 20 to 50 would be middle age, and then 50 to 99, whatever, would be categorized as old, and as you can see, that worked for me. Okay, for question 16, I used the drop fair function. I wanted to drop the fair values that are less than 20, so I used df.drop less than 20.index to do that, and it worked. As you can see, it dropped about 23 rows. So then lastly, almost lastly, I needed to set the index as passenger class, so I did df.setIndex, super easy. Then I saved it as a CSV file by doing df.toCSV. So lastly, based on what we did today, I believe the data could be useful to predict survival, because the correlation matrix did show a correlation between passenger class and survival. Also, there were some reddish colors on the heat map, which indicate a fairly strong relationship between the number of siblings and spouses and fares. So yeah, that's my Data Analytics QM 238 Project 1. Thank you.